It's an automated white box testing tool. So I won't talk really about it. I'm just going to show how it runs and works. I work a lot with the manual. I provide probably most of the bugs he's fixing these days. So we're really collaborating on this project. So the goal of this demo is to write a binary heap. So your old language writers, you probably know this data structure pretty well. So I won't go into the details, but it's a pretty neat data structure. And usually you have something to push elements, and then you have a peek method that gives you the minimum. And with the binary heap, the minimum is always at the first element of the array. So what I'm going to do here is mix a bunch of stuff. We're going to, write the code, write some contracts, do automated testing, do some kind of form of test-driven development, and maybe design by contract, and mix all of them together. So I tried to find an acronym to describe this, but I ended up with 10 letters in the name, so I gave up on that idea. So you'll see I like snippets to go fast. So let's get started with a heap. So we have a generic heap class, and it just holds a list of items. It has a count property, which is handy, and it has an add method. So it's pretty harmless right now. And what I can do is right-click in the method and say run PEX, right? And PEX is going to try to cover every reachable branch from add. And branches that are in your code. So we don't really care about the implementation of list, although we're going to analyze it. So in this case, we generated one instance of heap, and that was enough to actually get 100% code coverage. So that's the only test case we needed. So I'm going to do two things here. This is the PEX part. PEX saves your test as unit tests so that you can run them later. So I'm going to do that now. I'm going to tell PEX to save that because everything is in memory right now. And I'm also going to do some more setup. So I can click on the test. So to explain you this table, we add a value here. Oops, let's spin it. Spin this. Okay, so value gets mapped into this column, right? Target is the instance because it's an instance method. And then if there's an exception, we'll show in that row. And every row is a generated test. So it's a generated set of input that covers a different behavior of the implementation. So let's go ahead and save this guy. So to save a test, when you start unit testing, there's probably 15 steps you have to do to get the project right. So we automated that for you. And now you end up with a unit test. So this is a classic team test unit test. We support other test frameworks, of course, which creates the heap and then passes the heap into a parameter and into a method. And then this method is what we call a parameterized method. And maybe I get more space here. So that's the new thing that you can write with PEX. You can write tests that are open, and you leave those parameters open. If they don't matter, you let the tool generate that. Parameterized tests are not new. They were there for a while, but we provide a very smart data generator. So this test takes any heap and a value, and then it adds it. So it's pretty harmless and useless. So let's go and improve that. So first I'm going to tell PEX that I want an array. So I'm going to say, OK, I want an array that's not null, because I'm not testing the test code. And then I'm just going to add the values to the test. And moreover, I'm going to check that I actually get the minimum out of the heap. So I'm going to use, let's see, enumerable min values, and then I'm going to assert that min should be equal to target peak minimum. Okay, this is TDD. I just added a method to my heap which didn't exist. I can go ahead and go and implement it, right? So everything should be building. We're happy. It's not building. And why is it not building? Because I changed the signature of my test. So this is a classic example of problems when you have unit tests and a number of tests. You change your software and then bam, you have 100 tests now who need to be refactored. And why is that? Because now this test that I had has the wrong signature. It should take an array. So in PEX, we solve this problem pretty easily. Because this test is generated, well, just delete it. And then you're good to go. And there's another internal error. I'm going to silently ignore that one. All right. So let's go ahead and start writing this heap implementation. So I'm going to return a T here, and here I'm just going to return default T as a first step. Okay, where's my PEX view? Maybe you can run this. So if I run PEX here on the add method, whoops, that wasn't good. Let's try again. We are in a bad state right now. All right, so this is my dev machine, and somehow I shouldn't mess around before I do some demos. Let's try to run the test from here. And we have another issue. All right, let's start from scratch. And let's run the add method. So I'm losing precious time. Okay, we're back in a good state. And let me go ahead and redo the steps one more time. So I'm going to save the test. I'm going to modify the test. I'm also going to PEX had to generate the heap method. So I'm just going to accept that. So creating objects is not easy. And here is the factory, which you could customize in how you want to create the heap. There's many ways you can create an object from the public API, and we don't want to make any guesses. So let's add the values now. And let's see if that works. I need to delete the tests, run again. And this is not working. Okay, so we won't do a test. Let's write a test here. The demo is turning into disaster. Oh, that's not good. All right, so this should just work. We run PEX, and then it's going to generate a bunch of inputs. So we can see that, well, obviously, if we pass null into add range, we get a null. And then there are different cases. PEX is going to start unrolling the loop. And as you can see, the values don't matter right now because we're not really sorting. So what we want to do is add this check. And since I'm late, I'm just going to jump into a later stage. So this binary heap has a very interesting invariant, actually very strong. So we can write this guy and use and leverage the code contracts infrastructure. So here what I did is adding a contract invariant method, right? That is an infrastructure that is provided by the code contracts. And this invariant basically states that if you're the left child of the right child of the parent node, which is encoded as this special indexing, then you should be less than the parent node. So this is the binary heap invariant, and I've expressed that in an instance method, which will be called at the end of all public methods. And also I'm using the default compare, so we're not cheating here. And then there's a less method that calls the compare. And so this guy should be called at the exit of each add method. So now when I add this, come on, do this. Now I can see that PEX found actually a set of inputs that violates the invariant. I didn't really have to put the invariant anywhere. I could just leverage it. So really leveraging the runtime checking that contracts is providing, right? So at this point, the invariant is pretty strong. So I would need to, I really need to write a correct heap implementation, which is kind of annoying. Let's try to do the demo from here. So I'm doing the main over my values. And then I'm asserting that main should be equal to peak minimum. Okay, and I'm going to turn off the invariant to make sure I can beat. Let's see if that works. So there's no invariant now. but I've added the debug assert in my add range method. Oh, the event is still turned on. Okay, I think I'm gonna stop the damage here. So what is the message here? PEX can understand. PEX tries to cover every branch, and when you write post conditions, or you write invariants, or you write requires, and you use runtime checking, they become branches in your program. And when you use interface contracts, you add a lot of places where PEX can actually try to break your software. So those tools work really well out of the box. And because it's all language agnostic, you could write contracts in C#, FL, whatever language, and have them understood by PEX. PEX works at the MSIL level. So we provide a pretty good integration. On the shipping box, of course, this is my dev machine. It has some intermediate state. So that was the message. If you write contracts and you reach the boundary of the static checker, there is something else that can help you. You can use a tool like PEX, which does a dynamic analysis to help you write better contracts or to help you write tests. So I'm taking any questions. I'm not trying the demo anymore. Yes?
You mentioned support for other test frameworks.
Yes, we support NUnit, XUnit, MBUnit out of the box. Yes. I mean, it's just which attribute you need to emit. We actually don't support the whole feature set of those frameworks. If you use funky decorators and stuff like that, we don't support it. Any more questions? Thank you very much.